Hey guys, my name's Joe. I'm one of the co-founders of Aztec and also the product. Excited to be here today talking about what we're doing on Ethereum, and hopefully next year we can port some of this over to Ava. But yeah, we're going to be just discussing privacy and how we're using ZkSnarks to scale private transactions on Ethereum. Just a quick overview. I think we've only got 15 minutes, so we may skip through some of these slides, but we're going to talk through our new Layer 2 solution on Ethereum, talk about how we're using ZkSnarks and specifically our in-house developed PLONK snark for scaling and privacy. At the end, we'll have a demo of the testnet that we launched in October, and we'll talk a little bit about our programming language that we've been developing, Noir, which allows users or developers to program the semantics of a private transaction. Also think in this space, it's important to take a look back and see where we've come from. In January this year, it was the first time on a blockchain that we had kind of confidential transactions, at least on Ethereum, with Aztec 1. Tornado Cash kind of on Ethereum in February launched anonymous transactions, and they've seen really great growth. I think there's been about 100 million going through the protocol as of last month. And earlier this year as well, I think it was impossible to have a ZkSnark with a universal trusted setup. So you used to have to do a trusted setup for every single snark circuit you wrote, which kind of made them unusable for private applications. Our team invented PLONK, which is kind of one of the first efficient universal snarks, which kind of enables you to use a single trusted setup for all circuits, which is a huge breakthrough, and was only in the last year. So Aztec 2 is it's a layer 2 that currently runs on Ethereum, but the infrastructure can be ported to kind of any EVM compatible chain. The verifier is just a Solidity contract, and the rollup kind of runs off chain, so it's kind of chain agnostic. On Ethereum, it enables private sends by default, coming out at around 5,000 gas per transaction in the current iteration. We've kind of replicated a lot of the social key recovery best practices that contract wallets have used on Ethereum and baked that into the protocol, so you can use kind of friendly keys and friendly kind of names instead of Ethereum addresses. And later next year, we'll be adding kind of private access to DeFi and a contract programming language. So how does this all work, I guess, is a good place to start. Aztec is powered by PLONK, and it's really become a standard in ZkSnarks, kind of taking over from some of the rank 1 constraint system snarks, like Groff 16, which predated it. The main differences in PLONK is mostly the efficiency. For some kind of operations, it can be 10 times more efficient, and this enables recursion, which means you can validate snark proofs inside a snark. And as I mentioned earlier, the universal setup. And this breakthrough allows us to roll up ZkSnarks inside other snarks. So a lot of people are using ZkSnarks for scaling, but this breakthrough allows us to roll up a snark inside a snark, so we get scaling and privacy. The user generates a snark on the client, sends it to a rollup provider, and a further snark is used to bundle all those transactions together before they're validated on the blockchain. It's just a schematic showing kind of how that gets opt-in privacy for users. Funds are deposited to the network, private transactions are then sent to a rollup provider, and that enables funds to be sent confidentially and anonymously between all participants. And in terms of efficiency, Aztec 1, even though it was only less than 9 months ago, we've managed to reduce gas costs by over 200x, and I think shows how quickly this technology is developing. We're down from kind of over 1 million gas for a single transaction to 5,000 gas by using this scaling plus privacy design. We can fit 1,024 private transactions in a single Aztec block on the layer 2. I think looking ahead to next year, some of the exciting things that PLONK enables, and specifically the latest version, Ultra PLONK, is we can start using much more friendlier elliptic curves as signatures. So currently, most snark proving systems use kind of snark friendly curves. And the reason for that is just it's much more efficient to validate a signature over a snark friendly curve compared to some of the unfriendly curves. But with our PLONK research, we can actually start to validate both the Ethereum curve and the curve inside hardware security modules, curve 25519, and all the while doing that with very fast client-proof construction and still preserving user privacy as all the proofs are created on the user's device. The protocol supports short names, so you can kind of send funds to a nice alias rather than kind of a long hexadecimal string. And I'll show a demo of that at the end. And alongside this, because we're bundling snarks inside snarks, the core unit of a transaction doesn't have to be just a private transfer. It can really be anything. So we've been hard at work building a DSL programming language for the rollup. The first version of this is coming out in alpha at the end of the month. We're very excited to get some feedback on kind of, I guess, the language design and kind of hopefully growing this into an open source project that the community can use to create efficient snark programs. Cool, I'm just gonna share a new screen and we'll do a quick demo. So the network's live on the Gurley test network on Ethereum. We've got a block explorer at explorer.aztec.network and some interactive docs on developers.aztec.network. You can go into kind of the code examples and try different code out in real time, which makes it a lot easier to kind of test out the different API functionality of our TypeScript SDK. And we've also got a fun kind of interactive demo at terminal.aztec.network, which I'm just going to demo right now. So I've already set up this account with some private just test ERC20 tokens. The network can be used with kind of any ERC20 or ETH. So you can see here I've got a private balance of 996.8 of these tokens. It just says DAI. And I can do transfer. I can either transfer this to the user's kind of address or to an alias. In this case, I'm just going to send some funds to myself. And you can get a sense for how quick the client proof construction is. It's a little slower when Zoom's running, but it's around 10 seconds on a decent computer. And as soon as that's sent, we can head over to the Block Explorer. We can see that the transaction's been received by our rollup service, and in around 60 seconds, we'll produce a new block, kind of bundling up that transaction. In the kind of test net, there's pretty low transaction throughput because it's just developers using this. So we're only bundling up 2 transactions at a time, but we can scale that up to 1,024 transactions. As soon as this block is produced, we'll be able to head over to Etherscan and see kind of that the transaction is completely private, not being able to see both the balance or the sender or recipient. You can see that here, actually, the only thing that's kind of broadcast is nullifiers and data entries, and there's no kind of perceivable data that could be used. And we're really excited just to see kind of how this sort of technology, as we scale blockchains, is used for programmable payments, kind of expanding access to DeFi, and just making a blockchain kind of more usable, but also maintaining a user's right to privacy. just wait for this to be mined, and then we can, I think, wrap up because we've only got about 15 minutes. So it's just been published to the Gurley network, and as soon as this is mined, we can head back to the terminal. My balance will actually stay the same because I set it to myself, but that's kind of the end-to-end flow for scalable private transactions on Ethereum. And I think as we look to kind of other chains, increasing the throughput of the main chain will just mean we can do kind of even more transactions in a block and bring down the cost of these transactions for the end user. So yeah, that's just been mined. If we just, balance is still the same.